So last video we have discussed about pinnacle arrangement. Basic rearrangement I have given or mechanism, basic mechanism I have given. Now slightly extension of this pinnacle arrangement. In previous case I have given open chain compounds I have given. Now look at the cyclic compound. Here I have taken 1,2-diol of a cyclic compound. 4-membered cyclic compound I have taken. A reaction with sulfuric acid HCl or an acidic medium produces spiro compound. Now, diols are converted into another cyclic compound known as spiro compound. This is the first application part. Let us work out the mechanism for this one. First step is as usual, proton approaches to the OH. This is also a symmetrical one. Therefore, H plus can approach any OH group. So therefore, I am writing cyclic compound. Here I am writing OH and proton is approaching here, positive, remaining OH will be here. Now the second step is elimination of water, therefore minus H2O. And here elimination of water and migration is simultaneous. So therefore this carbon will be migrated. So therefore I am writing, first I will show the carbocation part. Elimination of water. Here the carbocation formation. OH will be here and this carbon is approaching here. Here only elimination of water I have done. Now this carbon is approaches. Already 4 carbons are there and this carbon is linked with this one. Then it becomes what? 5 carbons. So therefore the next compound will be like 4 carbons will be as it is. Now the 5th carbon is added here. Now here OH will be there and carbocation. And this carbocation, both are secondary only. Because of the pair of electrons or mesomeric effect, shifting of the pair of electrons is taking place. Therefore, that will be converted into first one 4-membered ring will be as it is, then 5-membered ring. And here double bond OH. Now the positive charge on oxygen atom, which is unstable. Therefore, this proton elimination will be taking place minus H plus. And that will be converted into 4-membered ring as well, 5-membered ring. So, starting compound contains both are 4-membered rings, but final product contains 4 and 5-membered ring. This is diol, 2 OH groups are there. This is single compound that is called as spiro compound, right? So, diols are converted into spiro compound. This is the mechanism. Here, what we have learned is elimination of water, shifting of carbon, that means migration of carbon will be simultaneous. But in 2 steps I have given, elimination of water, then shifting I have given. In the previous case, migration of alkyl group and phenyl group is taking place. Now here this bond pair of electrons are shifted here, so that will be converted to 5-membered ring. Let us work out another example for this one. Now I will write 5 and 5-membered ring. Four and 4-membered ring. Now I will take 5 and 5-membered ring. Cyclopentane compound. This is also cyclopentane. OH groups are there. 5 and 5 becomes what? 5 and 6 members. Therefore, this is 5-membered and this is 6-membered. Just like the previous one. Okay? Now I am writing the mechanism. This is a symmetrical compound. Therefore, H plus can approach from any OH group. Therefore, I am writing this is the pair of electrons. First step, protonation. This is the protonation part. This OH will be saying now elimination of water minus H2O. That becomes here carbocation. This OH group will be same, and this pair of electrons are shifted here. So that will be converted into 5-membered ring will be as it is. Now this becomes 6-membered ring. And here carbocation formation is taking place. And now due to the mesomeric effect, this pair of electrons are shifted here. Therefore, that will be converted into 5-membered ring, and this is 6-membered ring. Oxygen with positive charge, which is unstable. Elimination of proton is taking place, minus H plus. That will be converted into 5 and 6-membered ring. In the previous case, 4 and 4-membered ring. Now I have taken 5 and 5-membered ring. Now let us take unequal size. One is 4-membered, other one is 5-membered ring I take. Right? Now just check the total part. If you have any doubt, I'll clarify. Now look at carefully here. Sulfuric acid is there, H plus is producing. First example I have given 2 4-membered rings. That is converted into 5-membered ring. 4 and 5-membered ring. Then I have taken 5 and 5-membered ring. That becomes 5 and 6-membered ring. Now I am taking unequal, unsymmetrical compound. 4 and 5 I have taken. Now proton approaches to 4-membered ring, and that forms carbocation. Look at carefully. This is 5-membered. Now proton is approaching what? 4-membered ring. That forms oxonium ion. Here OH will be as it is. Then elimination of H2O is taking place. This part is eliminated. Therefore, you will get 4-membered ring. Here 5-membered ring. And this OH will be same. Now here the carbocation is taking place. Opposite to the carbocation, the electrons are approaching. So therefore that becomes 5 and 5-membered ring. This is 5-membered ring. This is also 5-membered ring. And here carbocation is taking place. Because of the mesomeric effect, it will be converted into, this is one 5-membered ring, this one is another 5-membered ring. But here it is a double bond with oxygen with a positive charge. Now minus H plus. This is eliminated here, therefore that becomes 5 and 5-membered ring. So this is the second application part. Cyclic compound with the diols are converted into spiroketones. Right? This is the second example. So we'll continue for the third application part.